Good day, everyone. All right, so today we're going to do a review of solving parallel lines and transversals with three variables such as x, y, and z. We are also going to be doing all the rules for our proofs, such as properties of equality and congruence, angle proof reference sheet, and also proving lines are parallel with their converse. Conversal. Oh my. All right, so we are on page 4. All right, let's do number 12. So in this case, the first thing we want to do is to kind of focus on the parallel lines. So the parallel lines are L and M, right? And usually what we do is turn this until it is the parallel lines are horizontal. And for whatever reason, that will make things a lot more clear. So when we had it like this, it wasn't quite obvious what we were doing. But when we turn it this way, it's more obvious. It's interesting. All right, so what we're going to do is, with this, we are going to focus on either X, Y, or Z first. In this case, we are going to focus on X because there's two of them. All right, so we are going to look at these two angles. Now, the question is, are they equal to each other or do they add up to 180? And how you decide that, if they're equal, that means that they are the same. If they are different, then they would add up to 180. So are they the same or are they different? All right, this angle right here, if I put the corner of my paper right there, is that acute or obtuse? Is it acute meaning small or obtuse meaning big? And this is bigger than the corner of my paper, so that one's obtuse. And this one right here is also obtuse. All right, so they're both obtuse. So focusing on this, so we have these lines are focused on here and here. And those two angles, they're both obtuse. So because they're both obtuse, we know obtuse is equal to obtuse. Just writing down the equation before we start solving just solves a lot of issues, such as before on the previous problem. We know that they added up to 180, so I wrote that first, and then I was able to do this. For whatever reason, even though I knew it added up to 180, a lot of people accidentally set them equal automatically, so be careful with that. In this case, yes, they are equal. So this angle is 9x minus 2 is equal to 5x plus 54. And all we're going to do now is solve. So I'm going to subtract 5x from both sides. That's 4x minus 2 is equal to 54. I'm going to add 2 to both sides. I get 56. I divide by 4, and x equals 14. All right, just so you know what was going on in my head, I'll do it one more time. All right, so we had 9, we subtracted 5, we got 4x. We had 54, we're going to add 2. All right, and then we had that 56, and we're going to divide by that 4, and we got x is 14. So that's how we got that answer. Now, every single time that you get x, what are you always supposed to do? We're always supposed to put it back in the picture for two reasons. One, to check ourselves. What we just did, is it correct? Does it become an obtuse angle like we said earlier? And are those equal? That's the first reason. The second reason is to help us find whatever else that they may need. All right, so in this case, I'm going to plug it back into here. 9 times 14, subtract that 2, and we pop out this angle right here comes into 124. And I'm putting it as far into that corner as I can. And this angle, 5 times 14 plus 54, I also get 124. And they were both supposed to be equal to each other, so I know I'm doing this right. Now that I have that, so that's awesome. Now that I have this, I'm going to find all of the other angles. So this angle is 124. To find the acute angle, I just subtract from 180. So 180 minus 124, this angle will be 56. Okay, so we subtract from 180. All right, so this is 124, that's 156, or sorry, that's 124, that's 56. Over here, this would be 124, and right here would be 56. So basically we're finding this. This is 124, 56, 124, 56. I'll zoom in here so you can focus on what I'm doing. All right, so I found all those corners. And then I can copy paste and find these down here. So this is 124 right here. And all these other angles would be 56, 124, 56. So this is 56. This angle right here is 124, and this right here is 56. All right, so now that I have all these beautiful angles, I can find the next part. This angle right here has a y in it. This angle also is 56. If they are the same angle, they are equal to each other. And all we have to do now is solve. So because they're talking about the same angle, they are equal. So I'll show you my calculator so you can see what's going on in my head. At 56, I'm going to subtract that 6. So 10y is equal to 50. Divide by 10, and I pop out with y equals 5. And I'm going to plug it back in to make sure it checked out. So putting it back into the picture, just in case that my equation has a typo in it, I always put it back in the picture. 10 times that 5 plus 6. Yep, it was supposed to be 56. That checks out. And then this angle right here, same idea. This angle right here is 15z plus 7 is equal to 124. They are the same angle, so I set them equal. And now we're just going to solve. So 124, I'm going to subtract that 7. I get 15z is equal to 117. Divide by 15. And I get z equals 7.8. Wait a minute, was I supposed to get a decimal? That's interesting. Well, always plug it back in the picture to double check yourself. So putting it back in the picture, 15 times 7.8, add that 7. If we pop out with 124, I know I got this right, and I do, and so this answer is also correct. And those are the answers for those three. So it is okay to get a decimal as long as it checks back out. All right, now we did number 12. Let's do another example, and let's go down to 15. So we're going down to 15. All right, so now it gets a little more difficult. So what we're going to do first is we're going to highlight the parallel lines. So we highlight the parallel lines. So if I make this line blue, anything that's parallel, I'll also make it that same color. So the same colors would be parallel lines. Okay, so now I need to focus on one angle at a time. So let's see. We have a 39, that's awesome. There's a Z, there's an X, there's a Y, there's another X. Okay, so there's two X's. So I'm going to focus on this right here. So if I focus, now what train took, now this is already horizontal to me, so that's perfect. Those parallel lines are horizontal. To get from this X to this X, that is this line right here. So I'm focused just on that. So I have these parallel lines and this transversal. All right, from red to blue, there's no lines that cut into it. That's this angle right here. And from red to blue, so on this corner, at the bottom left corner, is this angle right here. All right, so if I focus on that, are those angles equal or add up to 180? All right, so are they the same or different? All right, so this one right here is obtuse. It is bigger than let me try again. That is acute because it's smaller than the corner of my paper. So that's acute. And this angle right here is also acute. It's smaller than the corner of my paper. It cuts into it. They're both acute. That means that they are the same. So that means that they're equal. All right, so now that I wrote that down, let's actually solve. All right, so this angle was 4x plus 4 is equal to 7x minus 44. And we're just going to solve now. All right, so I'm going to get my calculator so you can see what's going on in my head. All right, I have 4. I'm going to subtract 7 from both sides. I get negative 3x plus 4 is equal to negative 44. I have that negative 44. I'm going to add that 4. I have negative 3x is equal to negative 40. And now we're going to divide by negative 3. Ooh, something's up. Maybe I did something wrong. Okay, so in this case, right here, do you see this part right here? I accidentally added 4. So you're not always going to get this right. I'm going to double check what I did here. right here, I was supposed to subtract. That right here. I was supposed to subtract 4. So let's try this again. So we were 4. We subtract 7. Right here, we have negative 44, and I'm going to subtract 4, and I get negative 48. Now divide by negative 3, and I get 16. It's 44. We subtract 4, and we get positive 16. So you're not always going to get this right, but when we were doing our work, something felt wrong, and I double-checked. So it's okay to get things wrong. You always, now that I have this nice pretty number, I'm going to plug it back in to double-check that this worked. All right, so here we go. We said it was 16, right? So I'll zoom out a little bit so you can see my answer. No, I'll just zoom in. It's okay. All right, so we have 4 times 16 plus that 4, and we get 68. And I'm putting it as far into the corner as I can. And then down here, 7 times 16, subtract that 44. This also is 68, so that's telling me I'm doing this right. Okay, now that we have that, we can find all the other corners. So I know I got this right. That's awesome. All right, so if this is 68, so 180, subtract 68, this angle will be 112. This will be 68, and this is 112. And around this one gets a little more tricky. All right, so from red to blue, all the acute angles are 68. So this is 68 right here. And then, but this one got cut, so I'm going to leave that one alone. And then this one got cut, so I'm also going to leave that alone. But I know all the way from here to here would be 112. That's nice to know. All right. Now that we have this, we have a lot of information. Now let's go ahead and find the other angles. Okay, now for y, it's kind of hard to find at the moment. You have a possibility of doing it, but let's go ahead and find z first. That looks like it's the easiest one. It's the closest to all the angles that I already have, right? Okay, so this angle right here, all of this makes a straight line. So there's 2 ways we can do this. At this moment, I know that 39, 15z plus 1, and 68, all 3 of these make a straight line, so all 3 of them are going to add up to 180. Or I know that these 2 all by themselves make 112. And a third way that I could do this, so I could do 1, 2, 3 equals 180 degrees, or I could do 1, 2 equals 112, or I can actually find what z is. So I know that 180, if I subtract that 68, and I subtract this 39, that this angle right here would have to be 73. That's nice. So that's 73 right there. Okay, so basically I'm saying that 39 plus that 15z plus 1 plus that 68 equals 180, right? All right, so with that, knowing all of that right there, that we would have, just trying to find that sweet spot for the camera. Okay, so with all this, 180, if I subtract the 68 and I subtract 39, I know that 15z plus 1, that right there, is equal to 73. Awesome. All right, now just solve. So 73, subtract that 1. I get 15z is equal to 72. Divide by 15, and I get z equals 4.8. Ah, I got a decimal again. It's a pretty decimal. Let's double check that it works. So put it back in the picture, just in case I have a typo. Put it back in the picture. I have 15 times 4.8 plus 1, that's 73. Yes, it checks out. And all 3 of those add up to 180. So everything works. So 39, that's 73 I just got, and that's 68. Yep, they all add up to 180. So I feel really good about that. All right, fabulous. Now, how are we going to find this other one? All right, let's see here. I know black and red right here makes 73. Black and red also makes 73. The 3 corners of this triangle. So there's a couple of different ways how to do this, but I think the easiest way would be the 3 angles of a triangle add up to 180 degrees. We can find that angle, and these 2 add up to 180. Or, there's a bunch of different ways. we find this corner right here, and we can do, and we can find this other thing. But I think 180 degrees would be the easiest thing. All right, so we know that a triangle, so 180, subtract 73, subtract 68, this corner right here is 39. So this is 39, and now I know that these two right here make 180 degrees. All right, so I know 8y minus 43 equals 180. Let me try again. 8y minus 43 plus that 39 equals 180. So if this is 30, so 180 minus that 39, I get 8y minus 43 is equal to 141. So that's one way to do it, or we could actually found that angle. 180 minus 39, this is 141. If 8y minus 43 equals 141, and then you would just solve. All right, let's do it. 141. We're going to add 43. We get 8y is equal to 184. Divide by 8. We get y is 23. I'm going to put it back into the picture to make sure it makes sense. We get 8 times 23, subtract 43, and we get 141. Everything checks out. So that was number 15. I'll zoom out a little bit, so if anyone needs to take a picture and copy that down, go for it. All right, so that was a nice review right there. Okay, so now let's actually get into our lesson today. So to get into our lesson, we're going to go to page 13. So everyone's going to go to page 13. Okay, so now we're just going to learn rules today. Just rules, real simple. We just did the hard part. So we're going to learn our rules. All right, so on page 13, wicked simple things. Okay, the addition property. All right, so the addition property. Okay, if A equals B. All right, so let's say we have A, and I'm going to leave some space, equals B, and leave some space. All right, so what we're going to do, we're going to add C and add C. There we go. That's what happened right there. So all we did was add to both sides. That's it. That's all that happened. That's the addition property of equality. There you go. That's simple. All right, let's do another one. Subtraction property. So once again, if A equals B, so we have A equals B at the moment. What do you think we're going to do to both sides? We're going to subtract something, right? Subtract C, subtract C. I'm just going to highlight that. That's all that happened. All I did was subtract C from both sides. That's the subtraction property. So what changed from here to here? We subtracted the same number on both sides. All right, so A equals B again. So I have A and I have B. All that's going to happen is I'm going to multiply C on both sides. That's all that happened. That's multiplication. All I did was multiply. Not very difficult, is it? It's really simple. All right, so A and B. So if I have A equals B, what do you think I'm about to do to both sides? I'm probably going to divide. So let's do it. So divide both sides by C. So that's all that happened. We're just going to divide C on both sides. All right, that's wicked simple, right? What did you do to both sides? So what changed from here to here? Did you add? Did you subtract? Did you multiply? Or did you divide? These are things you already know. Now you just know what the name is. Fabulous. All right, let's go to the next part. So I'm going to zoom down a little bit. Here we go. Distributed property. All right, so for the distributed property, if A times the quantity B plus C, then what does that equal? So what happens there? I multiply here, and that's AC, and I multiply here, that is plus AC. AB, and this would be A times C. And that's all that happened. All you did was distribute. That simple. So what changed from here to here? You distributed. That's what they're asking. What changed from this point to this point? You distributed. Okay, substitution property. All right, for substitution property, if A equals B, then A may be replaced by b in any expression or equation. That's it. All we did was replace it. And you're going to get a bunch of examples. So what we're trying to learn is what are all the list of properties and what do they possibly mean. All right, reflexive property. This one you're going to use so often. That is very important. This reflexive property. Not so much this unit, but then future units, it's going to be very important. For any real number a, a would equal a. Reflex property, or I used to call it the duh property. It's like really obvious. You're saying like my pen equals my pen. That's it. My blue pen is equal to my blue pen because it's the same pen. That's what you're saying. So a value always equals itself. That's what's happening. My blue pen is equal to my blue pen. That's it. Okay, symmetric property is if you have A equals B, you just flip it. B equals A. That's symmetry. You just flip them. So if A equals B, then B equals A. And then finally, the transitive property. All right, so think of a train. So transitive property. So if you have A equals B and B equals C, you're just going to cut out the middleman. So cut out the middleman and you get A equals C. So this has the same feeling. It feels like syllogism. So syllogism was the words. Transitive is actually the math. So it feels like syllogism, so you're just cutting out the train. And why syllogism? Because here are the train tracks is another way how to remember that. So you're just cutting out the middleman. So if A equals B, then B equals C. So that's the transitive property. So basically what we're saying is, so transitive property. All right, so if my yellow is equal to my orange and my orange is equal to my blue. So if my yellow equals my orange and so these two are equal and these two are equal, then if you just cut out the middleman, my yellow is equal to my blue. That is a transitive property. So if these two are equal and these two are equal, well, that obviously means that these two are equal as well. Boom. All right, that's transitive property. All right, let's keep moving. Two-column proofs. So we're going to be doing a lot of two-column proofs. All right, two-column proofs, a common format to organize a proof. So this is going to be used all the time, and that's what we're going to be practicing with. The left side lists all the statements, and the right side are all the reasons. And now let's actually do a couple of reasons we can do. We can do properties, definitions, postulates, and theorems. These are just this is just a list of possibilities here. And what we've been doing is like we have the addition property, subtraction, multiplication, and division property. So what we just did were all the properties. Later on, we'll talk about definition, postulates, and theorems. But really, you only truly just need the first words: addition, subtraction, multiplication. As long as you have the first key buzzword, then you should be fine. All right, so here we go. Let's actually do an example. All right, so don't freak out. You're going to be fine. Okay, so just focus on one thing at a time. So I'm going to cover this up to help you out. All right, here we go. The first thing you always do are your givens. They said, hey, 4x minus 1 is equal to 27. We have, I need you to prove that x equals 7. All right, here we go. I have 4x minus 1 is equal to 27. That's my given. All right, now what changed? How did I get from here to here? Well, what disappeared? That negative 1. What did you do to get rid of it? We had to add 1 to both sides. So because we added 1 to both sides, that is the addition property. So what changed? That is the question. How do you get from here to here? What changed? That's the addition property. Or if you just said addition, that totally right. That totally is correct. All right, now what happened from here to here? How did I get from 4x to equals 28 to x equals 7? So what disappeared? That 4. How did it disappear? To get rid of this 4, I had to divide 4 on both sides. So that right there, because I divided 4 on both sides, that is the division property. And I'm done. That's it. That's all we did. We added 1 to both sides and we divided by 4, and we're done with that problem. Fabulous. Okay, so now that we have that one done, let's go ahead and go to the next page, and we're going to go to page 14. All right, so these are all the properties you just learned. Adding, subtracting, multiplying, dividing, and the distributive property. We know about substitution. We know reflexive property, where like A equals A. We know symmetry, where you have AB is equal to BA, you just flip it around, and transitive. A equals B, B equals C, so thus A equals C. All right, so you don't have to write those down, but I just like to have them all in one spot. So these are all the things you just learned a second ago. And you're like, you know what? I actually know all those, which is awesome. Okay, so so continuing that, we have some of the same properties we just talked about a second ago. So these are properties of equality. Now we're doing properties of congruence. What is the difference? Well, we'll talk about that in a second. So reflexive property. We have any segment AB, so that would be AB, that line segment is congruent to AB. So the difference between this one and this is a number, and this is a segment, a line segment in this particular case. So that's the difference. This is just straight up number, and then this is, but basically that doesn't matter. We just care about the word reflexive. So if you get, it still works. It's still the reflexive property. That's not going to change. So my blue pen is equal to my blue pen. It's still the same. Symmetry. Hey, didn't we do that a second ago? It's just flipping it around. So if we have AB is congruent to CD, we'll just flip it around. We know that CD is congruent, so that's equal sign with a squiggly above it, to AB. That's it. That's the property of symmetry. All right. And then transitive property. So that's cutting out the middleman, right? We're just cutting out the middleman. So if I have AB is congruent to CD and CD is equal to EF, all we're going to do is cut out the middleman. So that would mean that AB is equal to EF. So that's the same thing as what I talked about earlier, if I have these markers. All right, so if AB is equal to CD and CD is equal to EF, cut out the middleman, AB is equal to EF. So if my orange equals my yellow and my yellow equals my blue, cut out the middleman, my orange equals my blue. Simple as that. It's the same thing as what we talked about just a minute ago. Those were just numbers before, and now we have line segments. Same idea. Just as long as you have the first buzzword, you're totally fine. So if you say reflexive, symmetric, and transitive, you still have the right word. Sweet. All right, next one. Definition of congruence. Segments are congruent. Sorry for the typo. Congruent. Segments are congruent if and only if they have the same measure. So in this case, so AB is equal to CD, then, is congruent, so the line segment. So if they're congruent, then the numbers are equal. So the difference is I went from congruent to equal. That's all that happens. That is a definition of congruence. So if I said my blue is congruent to my orange. So if my blue is congruent to my orange, that means that they're also equal. That's it. So if blue is congruent to orange, then 5 would be equal to 5. That's all I'm saying. All right, same idea. The mirror image. So AB is equal to CD. So if 5 is equal to 5, then my blue pen is equal to my orange pen. So they're congruent. So that's all that happens. So if the lines are congruent, then they're equal as well. If they are equal, then they're congruent. That's the definition of congruence. Okay, and then try to fix this. A wire stuck underneath. There we go. All right, so now definition of midpoint. All right, you actually know this already. So if M is the midpoint, then AM is equal to MB. That's it. Boom. So if I have AB and M is in the middle, then I know that AM is equal to MB. That's all that happened right there. Okay, and then the segment addition postulate. So that's wicked simple. So left plus right equals the whole shebang. So AB plus BC is equal to AC. Whoops, only helps if you can see it. Okay, so these are all rules that you actually already knew, which is fabulous. All right, let's keep going. All right, so that was page 14. Let's go to page 18. So we're going to flip to page 18. So we're just learning the rules today. So let's go to page 18. All right, so page 18. So here are all the properties that we just learned. So adding, subtracting, multiplying, dividing, substitution, reflexive, symmetric, transitive, and then the properties of congruence, that's reflexive, symmetric, and transitive again. See how these two sets are the same. All right, we also learned about the definition of congruence, about the angles, definition of angle bisector. Okay, that's something new. So angle bisector. So that's when two things got cut by an angle bisector. So it cut the angle in half. So we already know about that. So just in case you want the picture, so angle bisector, if you cut this angle right here, this angle and this angle are equal. So if all of this was, let's say 60, then this would be 30 and this would be 30. So that's the angle bisector. Definition of complementary angles, they add up to 90. Supplementary, they add up to 180. These are things you already know. Perpendicular lines are right angles. And definition of right angles, if it's a right angle, then it's 90. These are things you already know, you just didn't realize it. So really obvious stuff. So don't freak out, we're just going to let this simmer. All right, let's keep going. All right, so this right here, the angle postulate. So that is the top plus the bottom equals the whole shebang, right? So I would say, let's call this X, this call Y, and all this is Z. So basically we're saying that X plus Y equals the whole shebang, Z. That's basically what we just have. This plus this equals the whole shebang. That's basically what just happened. All right, vertical angles. That means this angle is equal to this angle, and vice versa. This angle is equal to this angle. So those are equal to each other. So these are things that you already know. You just kind of didn't realize you knew so much. Okay, complement. So a right angle. So if two angles are a right angle, then they are two angles form a right angle. They're complementary. So this is the same thing we talked about a second ago. Definition of complementary angles, complements of each other. Supplement theorem. So if two angles form a linear pair, they are supplementary. So linear pair means supplementary. So right angle means complementary. Linear pair means supplementary. Congruent complement theorem. So if A is complementary to B and C is complementary to B, then A is equal to C. All right, congruent complementary complements theorem. So that's cutting out the middleman. That's not used often, but it still exists. And then same thing with here. So in A is supplementary to B and C is supplementary to B, then A equals C. So how can I explain this? So basically it's just cutting out the middleman. So it's like syllogism again, where you're cutting out the middleman, right? Or transitive. So cutting out the middleman with 90 degrees. And this one is like syllogism. but with 180 degrees. So you're just cutting out the middleman. So if you don't learn these, that's okay. They're not used very often. We usually just use the transitive property to take its place. So it's totally okay. All right, so that's 18. And finally, let's go to page 23. Let's go to page 23. All right, so we're on page 23 here. All right, so on page 23, we have corresponding angles, converse. So here's the awesome part. We know the rules, right? Corresponding angles are equal, right? Well, the reverse works too. If these two are equal, then that means that the lines are parallel. So that's all this is. So, so 23. Okay, so in this case, right here. So if angle 1 is equal to angle 5, then L is parallel to M. That's all that happens right there. So if these are equal, then it works. All right, alternate interior, that would be 3 and 5, right? So if 3 is equal to angle 5, then that means that the lines are parallel. Alternate exterior, so exterior angles, that'd be like 2 and 8. That's an example. So if 2 is equal to angle 8, then the lines are parallel. That's all that's happening. So what kind of relationship do these have? And consecutive interior, which means same side interior. So that would be like 3 and 6. So if 3 plus angle 6 equals 180, then the lines are parallel. So basically, if the equation is happy, then the lines are parallel. So these are things you already know. All right, last thing. So let's actually figure out what these are. So what lines would be parallel? So we have 2 and 4. So we have 2 and 4. What train did we take? We took A. That's the A train. So what lines would be parallel? These two lines would be. So if I turn my train and I made it vertical, so here's the train to go from 2 to 4. These two would be the parallel lines, and that is C and D. So we're looking at this right here. So so it's C and D. And then what kind of angles are those? Those right there, they are copy paste, so that's corresponding. So we're talking about A would be parallel to B because they're corresponding. All right, how about 5 and 10? All right, so here's 5. Here's 5 and 10. Here's the train. So we took the C train. What lines are parallel? That would be A and B. So A would be parallel to B. Shoot, this is supposed to be C and D. Sorry about that. All right, so A is parallel to B. And those angles right there would be 5 and 10. That would be alternate interior. All right, and that should give you a nice little example. And let's skip down to F. Okay, 11 and 16. Okay, we did not take a train. We didn't even leave the train station. So if we didn't leave the train station, there's no parallel line. So this is none, and so we don't care. And the reason is because these are just vertical angles. So that's why this did not work, because we didn't even leave the train station, so there was nothing to do. And that's it for the day. So hopefully that helped you guys out. Have a great and awesome day.